Welcome to all. This is S. Muthukumar, Associate Professor from Department of Mathematics, K.S.Rangasamy College of Technology. In this video, I am going to explain about analysis of variance, particularly one-way classification. What is meant by analysis of variance? It is abbreviated as ANOVA. Analysis of variance is a technique that will enable us to test for the significance of the difference among more than two samples. It is a statistical method used to compare the means of three or more groups. ANOVA calculates F statistics to estimate the ratio between the group variability to within the group variability. In general, F test is used to find out the equality of two samples. Suppose if we want to find out the equality of more than two samples, means we have to use the analysis of variance technique. Assumptions to be made in analysis of variance are: the first one is each sample is drawn from a normal population. Population variance are equal, that means parent population variance are equal, and each sample values are independent to other values. There are three types of analysis of variance are followed. The first one is one-way classification. It is also known as completely randomized design. The second is two-way classification. That means a randomized block design. And the last one is three-way classification. It is also known as Latin square design. One-way classification. In one-way classification, the sample values are classified according to only one criterion. That is, in this case, single factor is considered for the evaluation. For example, comparing scores of students from four different subjects. This is the one-way classification ANOVA table. It combines the values of sum of squares, degrees of freedom, mean square values, and F ratio. This one-way classification is explained in the following example. The following data represent the number of units of production per day turned out by four different machines. Test whether the workers are differ significantly in the performance. There are four workers outputs are given. We have to verify these outputs are equally distributed or not. Here the only one criterion, that is output of four workers, is considered, so it comes under one-way classification. So to check the equality of these four workers' performance, we have to apply one-way classification technique. The step-by-step procedure for one-way classification is explained here. First, we have to set up the null hypothesis and its alternative form. In null hypothesis, we have to assume that the workers do not differ significantly in the performance. That means all the workers are equally performed. In alternative hypothesis, which is complementary to the null hypothesis, in this case we have to assume that the workers are different significantly in the performance. Now we are checking this null hypothesis. First, identify the given elements. Here n stands for total number of elements, n equal to 20. Then C, number of columns, that means classification of workers 4 A, B, C, D. then total, it's a sum of all the elements. Next, select the level of significance alpha. So in this problem I have selected as alpha equal to 5%. The first step involved in one-way classification is calculating the correction factor CF. So CF equal to t square by n. Its value is 2880. The next step is find out the sum of squares between columns, that is SSC. Its respective formula is sum of column 1 square divided by size of column 1 plus sum of column 2 square divided by size of column 2 plus etc. minus CF. In each case we have to subtract the complementary function from the sum of squares value. So first take the sum of the first column, these values. So its total is 50. 50 divided by 50 square divided by 5. 5 is the number of elements in the first column. 50 square divided by 5 plus 55. This is the sum of second column square value divided by size of second column. Sum of third column is 65. 65 square divided by 5 plus sum of fourth column 17 square divided by 5 minus CF value. Then SSC equal to 50. Next to find out the TSS. TSS means total of sum of squares. So in this case square the all the elements and total it. x1 square plus x2 square plus x3 square, there are 20 elements, so plus x2 square minus, then subtract this sum by the correction factor CF. So 9 square plus 10 square plus 13 square plus 9 square plus 9 square plus 13 square plus etc. 15 square minus the CF value, which is equivalent to 226. Next, using these two values, find out the SSC. That means sum of squares within samples. So in the column we are calculating the variances between the column. In SSC we are calculating the variances within the columns. So its respective formula is TSS minus SSC. Then TSS equal to 176. Next to formulate the one-way classification on our table. So source first, as in the first column for source of variance, there are two different variation. This one is between column and the second is within branch, that means within columns. The second column is assigned for sum of square values SSC. Then next one is degrees of freedom. For column values it is defined as, that means degrees of freedom, V1 equal to C minus 1, number of column minus 1, V1 equal to 3. Next to find out the mean square values, MSE, mean square values between columns. It is evaluated by the formula SSC divided by V1. Therefore MSE equal to 16.67. Then similarly formulate the second row for the within branch values. So SSE 176, its corresponding degrees of freedom V2 equal to number of elements minus number of columns, then V2 equal to 16. Next to find out the mean square value between brands, within brands, SSE divided by V2. MSE value equal to 11. The F test between the values MSC and MSE. Based on these two values, we can define the F ratio formula. Generally, F ratio equal to greatest value divided by lowest value. Among these two, the greatest value occurs for MSE. So in this ANOVA, the F test is defined as MSE, highest value divided by the lowest value MSE. Therefore, F calculated value, F test value is 1.515. Based on this formula, next define the degrees of freedom. The first value is for numerator term and the second value is for denominator term. Here df equal to its corresponding degrees of freedom 3, 16. Next select the enabler values at 5% value. For this degrees of freedom 3, 16. Here the enabler value is 3.24. Now compare these two F values. The first calculated value is less than the enabler value, that means 1.515 less than the 3.24. So in this case our H0 is accepted. That means the workers do not differ significantly in their performance at 5% level. All the workers are performed equally level. So this result is accepted. That means our null hypothesis is accepted. So these are the procedure for checking the equality of more than two groups by using analysis of variance in one-way classification. These are some sample problems. Try to solve it. Thank you.